Hey, hi, hello guys, welcome back to Code with Nani channel. So today we're gonna discuss about lead code problem of the day, number of subarrays with odd sum. So you are given integer arrays, return the number of subarrays with an odd sum. So since the answer can be very large, you need to return the modulo 10.1e9 plus 7. So what the question is about? So you are given an array. So you are given array 1, 3, 5. So you need to return the total number of subarrays with the odd sum. So what are the subarrays that is possible for this array 135? So subarrays are 1 3 4 9 3 8 5 1 1 plus 3 4 1 plus 3 plus 5 9, then 3 3 plus 5 8, and just a 5. So these are the total number of possible subarrays for this particular array nums. So what is the count of the number of subarrays with odd sum? So this is an odd sum, this is an odd sum, and this is an odd sum, this is another. What is the count? Count is 4. So how do we approach? So the very brute force approach for this particular problem is you can iterate through each and every element and find out all the possible and j equal to 0 to j less than I. So you can find out the all the possible subarray sum, and you need to count the what are the subarrays that ends with an odd sum. So that will be a very brute force approach, and the time complexity for the particular solution is O of n square. But here, as the constraints are considered, it is n is less than or equal to 10 power 5. So if you write the O of n square solution, so it definitely gives you the TLE, which is time limit exceeded. So in order to solve this problem, we need to write the solution in such a way that it should be of n log n, or it should be less than of n log n. It should be of n or n log n. So both are fine for this solution. So what is the intuitive approach solution? So in order to solve this problem, I recommend you to solve this particular problem, which is subarray sum. You will find this in the Leetcode result. Subarray sum with k, which means basically you need to find a subarray sum of k. So we need to return the total number of subarray sum with the k as the sum. Okay. So if you are able to solve this problem, we can easily solve this particular problem. So what is the intuition of this particular problem? So suppose suppose we have an elements 1 3 5 8 9. Suppose you are in this, if you consider the prefix sum, okay, because we need to write in such a way that it should only follow a one loop or a offline log. So we'll consider the prefix sum. Okay. So what will be the prefix sum? Then the first element, it should be 0, then 1. So 1 plus 3 4, 4 plus 5 9, 9 plus 8 17, and 17 plus 9 26. So this will be the subarray sum. Sorry, prefix sum. So at any particular index I, okay, at any particular index I, so if the subarray sum ending with this particular index, which is an odd, which means the prefix of, so how do we find the range sum? Suppose if we are in a particular element, like suppose you are in index 4, and you need to find the subarray sum ranging from 2 to 4. So how do you find? So how do we find? Using prefix sum. So prefix of r minus prefix of L minus 1. So that will be the sum range sum. So in this way we need to find. So if you think we are ending at a particular index with an odd sum, what will be the sum? Suppose if it is an odd sum, which is because it is an odd sum, and the particular ending sum is also an odd. So what should we subtract from it to get an odd sum? So we will subtract from the even number, because if you take the case odd plus or minus odd is even, you can take the case 3 plus 3 6, which is an even. 3 minus 3, suppose 6 minus 3 sorry, 9 minus 3, 9 minus 3, 6, which is an even. So odd plus or minus odd is an even. Even plus or minus odd, which means 3 plus 2, you can say odd. And odd even plus or minus even is still an even. So in this specific case, if we are subtracting, if we have an odd number and in product is also an odd number, so what is the element that we need to subtract? It's an even. So if we want to calculate the total number of subarrays that is ending with this particular index, which gives the odd integer, it will be, we need to count the total number of even elements. If suppose we have a even elements, two even elements, because 0 and 4, so we can have a total subarray sum in this way or in this total sum or only this. So total will be 3, which is total sum plus total sum 1 plus how many elements that we have encountered during our um, left side of this particular index. We have a total of 2 even index, which will be 3. So if in other case, if the current element is an even number, suppose in this particular element, suppose 1 4, so prefix sum is 0 1 4 9 and so on. So if we are ending in this particular index, which is an even sum, so what will be what end product we need? Odd sum. So what we need to subtract from here? So even minus odd will be odd. So we need, if we encounter a odd prefix, even prefix sum, we need to count for the odd index. In vice versa, if we encountered a odd prefix sum, then we will add the total number of even subarrays to that particular answer, and we'll just return the total answer as a value. So as you see, as we are encountering prefix sum from 0, as the zeroth index, we are initializing with the 0, because as we see, prefix of I equal to prefix of I minus 1 plus nums of I, right? So in that case, in order to get rid of the minus 1 case here, we're just initializing prefix of 0 as 0. So in that case, what will be the even count? As 0 is also will be considered as even, so even count will be initialized with 1 and odd count will be initialized with 0. So from then we'll iterate through this prefix sum, and what will be, if we encounter a particular subarray sum as an odd, we will add the total number of even subarrays, and vice versa, and we'll finally return the answer variable. So I'll just walk you through the code and you'll get clear picture about my intuition. So let's just shift. So I'll just zoom in. So what we are doing, as you can see, since the answer is very large, we need to return the modulo. So I'm just initializing the constant into modulo 1e9 plus 7. So instead of storing the prefix sum in an array, what we are doing is we're just adding each element to the sum, and we are checking at each and every prefix sum. So we don't need to take any prefix sum array, we can just use some variable. Okay, and as I told you earlier, we are initializing the prefix of 0 is 0, that's why we are starting with the even count 1 and the odd count 0, and the answer will be the count of the odd sum arrays, and they are initializing with the 0 as well, and we are iterating to the array, we are just adding the current element to the sum, so that we get a prefix sum ending at that particular index. So what we are doing here is, answer is equal to previous count plus, if if the present if the present prefix sum is an odd, then we are adding even count. So ans plus even count, or else if the current sum is an odd, current sum is even, then we are adding or to this answer and just modulo. So what we are doing is just modulo, because there may be a case where the count is very large, so that leads to an overflow of the integer. That's why I'm just modding with the my answer as well as the count of this particular even count or odd count. I'm just moduling. So we are just adding to the previous answers to whether if it is an odd, we are just using even subarrays, or in the vice versa case. Suppose if it is an even sum, if it is an odd sum, if it is an odd prefix sum, then we just incrementing the odd count, or else this is terminator operator. If it is an even sum, then we'll increment even counter, and in the end we are just returning the answer. So just a simple 5 lines of code. Just run the code. Let's submit the code. Hola, and submitter. And that's it for the today video, guys. So if you like the explanation of this solution, do like my channel, subscribe to my channel, and hit that bell icon so you never miss any notification from my channel. And that's it for today video, guys. Thank you. Tata. Bye bye. See you tomorrow.